This video is going to be for Design and Communication Graphics PN 4025 for week 9. Now this week's topic or topics we're going to be covering are developments and envelopments, as well as intersection of solids. Now the two of these kind of go hand in hand, because typically you'd get an intersections of solids question, which then gives you a section where you have to develop out a part of that object that has been intersected by another object. Now you'll see this as you travel through the development and envelopments. You'll see that it leads on from that into intersection of solids, and sometimes depending on the book it might do it the other way around, but they tend to be grouped together, and oftentimes the questions are somewhat merged. As you can see here, this is just an example of developments and envelopments. You should all be familiar with this by now. A very, very basic concept of an object itself being developed out. If you have travelled through the Junior Cert curriculum or the Leaving Cert curriculum, or both of them, or have not yet, you should be very familiar with this. And even if you haven't, this is typically stuff that even be covered in primary school curriculum, in the visual arts and things like that. Now this is a very basic example of developments. Now this is as simple really as it gets. You have an elevation and you have a plan, and you provide it with all the true lengths in that elevation and in that plan. So any of the true lengths that you need to develop out that surface have been provided to you in elevation and plan. Now this is just an example of me traveling through a basic question. Now it does have a bit of a tougher section to it, where a circle has been elongated because this object actually has been cut through by a circle. So you can imagine a circle has been placed on the surface and extruded a cut straight through it, or as if a cylinder has actually passed through the center of the object itself. Now for anyone who has not yet covered this topic or hasn't done even Junior Cert level technical graphics, this might be important for you to travel through. Otherwise, do not worry about it. Extremely simple. It's just traveling through the very basics of a development question. As well as that, as the questions get a bit tougher, so this would be an intermediate level question. Now, not because of the actual shape itself, it's because of the constructions used to find out the development or to develop out the shape. As you can see here, we're dealing with an object where we're given elevation and plan, and we're actually missing information. Now here, you're not given all the true lengths that you need to develop out that shape itself. This question, you can see that all the lines that are traveling to the apex from the base of the object, we don't know the lengths. As you can see there, there's a bit of construction happening there to find that true length of OC as indicated on the drawing itself on the left hand side. But that's fine for you to understand the construction, or sorry, for you to know the procedure of completing that construction, which most students do get to in Leaving Cert level and Junior Cert level. They understand the construction well, they understand the steps that you take. But now we need to get a deep understanding for what is happening here of the actual rotation of the line in plan, to find it in a rotated state in elevation where it is a true length, where you're looking perpendicular at that line. Now I actually have a video here traveling through a solids work model explaining that actual construction itself happening, that you might actually find helpful to save and maybe use in your classroom sometime, or even develop a model similar to it that will help you explain it depending on the actual object that you're dealing with. Now one thing I would say about that is that this is an extremely basic looking question, and even at that, the construction looks extremely basic, and the understanding might be something that you get to terms with fairly quickly if you apply yourself. But depending on how the question is asked and the position of that line, the understanding will really be tested, because the construction might not look like it's correct because of the location of the line itself. Now, because it's resting on the horizontal plane of the object itself, I think that it makes it easier to understand where heights are coming from. But when you have a tougher question, this will really be tested. So I would apply yourself and understand this construction, especially as it is shown here and is shown in the video. And then for tougher questions, you'll be able to apply that knowledge and complete that construction to find your end solution. Now this would be an intermediate question where you kind of bring in curves and things like that. You can see here that, you know, for a curve, what you take is the apex of that curve itself, and use your compass to describe the lines and take heights. As well as that, you can see we're using generators traveling up through the sides of the cone here. You can see that's broken up into 60-30 set square in the plan. As them lines then travel up into the apex, you can see where they're actually touching off that cut section itself. Now, depending on the question, you might be asked to form that actual plan, that cut section, as well as that then take that information that you've gained by developing that, let's say, ellipse here, that elliptical shape, and then using that heights as the generators travel up through it to find them over here in your development. Now again, still it's a fairly easy question all up, because it's a basic shape. Now when you have a lot of different objects stuck together and there might be ones intersecting each other, that's when the complexity comes in, when the lines and the points nearly start coming on top of each other and things get a bit confusing. What I would say there is labeling. You can see here they have a great use of labeling, clearly labeling each one of the points sequentially throughout. Now if you want to use numbers, letters, Roman numerals, whatever, if you want to use a combination of all of them to help you understand what is happening in the drawing, then do that if it benefits you as well as benefits the people that you're explaining the drawing to. And here's just an example of an advanced question. You can see here it's a bit more of a complex shape. Now there's not any curves in this, but there is lines that you might not have the true length to, especially that actual shape that's cut out of the actual object itself. So for this, I won't say that it's unachievable. It's very, very achievable even for an ordinary level student. It's just that when you're dealing with so many points, again, labeling is key, not to get confused. You can see there in the plan and elevation especially, it gets a bit hectic. Now for interpenetration of solids, this is really where two objects collide. So you can see here or actually intersect each other. You can see we have a cylinder and we have a cone, and you see the cylinder itself is actually traveling through the cone on the far right hand side. Now in a question that provides you with something like this, what you will have to do is draw out that curve, that curve of intersection, that intersection line. So as you can see where the blue actually meets the red, that line itself, you're going to have to find that, and that oftentimes can be a tough thing to visualize, especially the shape that it might form when it's cutting through the object. If you were to imagine in your head the two objects actually colliding before looking at the object on the right hand side, you might not actually visualize the shape of that cylinder where it's being cut to be different than it actually is. So it's important to take note of that. So as that, you can see that here a bit clearer in the elevation plan in view that's provided. So as that there's different methods to identify points on this curve. It's important for you to open up that book, that David Anderson's book, or any other graphics book that you have, and look through the constructions that they use to locate points. So you can see here in the plan, you can see there's a line traveling from the apex down to the base circle, and it intersects that curve in two different points, P and Q. And you can see how that relates back then to our end view, where them points were first located to actually be used to find the curve in the elevation and in the plan itself. So take your time, try to break down the drawings, see where the points are coming from. It's very much just you need to spend time watching it and seeing what happens. The great thing with a question like this is that, for instance, in your end elevation there, you can see where P and Q is. You know there's going to be 2 points the exact same on the other side of the central axis going down from A, so you know that curve is going to be repeated again. As you can see in plan, it's going to be like a mirror image, so you can imagine a butterfly, the two different sides of them. Now if we move on, we have our two different questions, our lab activities. So this lab activity, it's fairly basic lab activity. It shows you a cone with a simply inclined cutting plane traveling through it. It wants you to develop or to finish off basically the plan itself, developing out that shape as you can see it in the plan after the section has been cut out, and then to develop it out. Now ensure that you label everything. keep things numbered as well as you can to ensure that you're showing that you are capable of breaking down this question and traveling through it slowly and logically, so that someone else watching it could learn something from it. As well as that, we have a second lab activity. This one's a good bit tougher. This is where your interpenetration of solids are coming in, when you have one object that's after traveling through another object, which here's a square itself, has been cut straight out of a hexagonal base pyramid. Here, having an understanding for your rebatment will definitely come into play. And it will test your knowledge. You might have to complete the 3 different views to finish it. You might have to do an elevation, a plan, and an end view, depending on the way in which you tackle this question to ensure that you've located all them points. It is tough. Just take your time and number everything as best you can, or annotate it, and that should clear a lot of things up for you. After that, just ensure that you travel through your checklist for this week. As you can see here, you have your first lab activity, your second lab activity. We actually don't have a tutorial, principle sheet for this week. Use that time, that tutorial slot, to look at your activities, ensure they're right. Maybe travel back to some of the previously covered topics. Even link some of those principles that were previously used that might be at play with this. With these 2 drawings. For example, like you are using your orthographic views, depending, you might need an auxiliary view depending on what way you tackle this. As well as that, you're obviously using rebatment, which is rotations to an extent, and there's plenty more principles at play that you can link back to this that we've previously covered in other tutorials or other principle sheets. As well as that, just ensure that all elements of this has been submitted to Solus by Sunday, which is going to be end of week 9.